about energy. We talked about energy moving through an ecosystem. And remember, we ended with the concept that energy cannot be recycled. We lose some energy each time we convert from one form to another, each time one organism eats it. Every step of the way, the second law of thermodynamics says we're going to lose a little bit of energy. If you lose it, you can't recycle it. That is not true of matter. Matter would include all the essential nutrients, all the individual atoms that are moving through an ecosystem. And those atoms, although they can be put into new compounds, are not destroyed. So we do have the ability to recycle matter. So we couldn't recycle energy. We had to have a continuous source. And for most of the planet, that continuous source is the sun. But for matter, we can cycle matter. And there are what we will call biogeochemical processes. So they involve both biology and geology, because those chemicals are part of each of those systems that allow us to do that. So for this section, your objectives are to be able to describe how nutrients move through a biotic and through the abiotic parts of an ecosystem. The biotic parts of the ecosystem are those that are living or once living, and the abiotic parts of an ecosystem are the parts that were not alive, are not alive. So this is the geological part, and this is the biological part. We're going to look at why nutrients are important to living organisms, and we've actually already looked at that when we looked at Chapter 6, Chemistry and Biology. And we're going to look at some of the more common biogeochemical cycles of nutrients. So we have cycles in the biosphere. Again, matter cannot be created or destroyed, just like energy can't be created or destroyed. But unlike energy, the atoms are not lost. If you take a sodium chloride molecule, a table salt molecule, and use that sodium to build an ATP molecule, that sodium is still sodium. The sodium chloride is gone, but the ATP molecule is now there. So the atom of sodium is never lost. We don't get new atoms of sodium. We don't lose atoms of sodium. But they can be rearranged into new compounds. So we don't get new matter coming in. There's no source of matter like we had for the energy from the sun. But we don't have matter leaving the ecosystem, the biosphere, either. Those atoms that are here have been here for as long as the planet has been here, and will continue to be here for as long as the planet is here, unless we do something like send them off into outer space. So one of the first important molecules we're going to look at is water. And you've all looked at water before, the water cycle. I'm sure you took a trip to the Holton Water Company way back when, and learned about the water cycle and processing water, especially how they take surface water and groundwater and prepare it for human use. And we remember from Chapter 6, especially the third section of Chapter 6, that water is the most important part of living organisms. It is the most abundant. It is not a living thing of itself, but life requires it to be there. And this is a cycle. We can start anywhere, but let's start with the atmosphere, up in the air. In the atmosphere, water gets to the atmosphere through either evaporation, in which the heat from the sun causes the water to turn to steam. The steam rises and goes into the atmosphere. Or also, something you may not recall right away is transpiration. And plants give off water through their leaves in a process called transpiration, and that puts water in the atmosphere. That evaporation and transpiration puts water vapor into the atmosphere. The water vapor condenses around particles of dust in the air to form clouds. And actually today we have a pretty cloudy sky. If you look out tomorrow, if you're watching this tomorrow, may not be as cloudy. But that will lead to precipitation, and that precipitation will fall in the form of rain. or snow, or some other frozen mix, sleet, land on the surface, or actually it will land on the surface. As it lands on the surface, it can end up in oceans, can end up in rivers, it can end up in lakes, it can end up just on the ground where it will run off into those bodies of water. And some of that water is going to make its way underground. It's going to be filtered through the root system of plants and go down and become water that's in the soil, and that water in the soil can go into groundwater, and that groundwater, as well as these surface waters, can be used for us and can be used by organisms. So we have a nice cycle, so that a water atom might start out being sprayed on this farmer's field. It's going to be used in photosynthesis and made into oxygen, some of it, and we'll get to that cycle in a moment. Some of it is going to be transpired off the leaves of this farmer's crop, make its way into the atmosphere, condense on a cloud, precipitate, fall back to the earth, may go into the soil and down to groundwater. Very nice water cycle. The carbon and oxygen cycle, we spent a lot of time talking about. We called it photosynthesis and respiration, but it's really the carbon-oxygen cycle. So we have carbon dioxide in the atmosphere. That carbon dioxide is taken up by producers through the process of photosynthesis. That carbon dioxide is converted into glucose. That glucose is used by the plant and by organisms in the food chain, food webs, and in that process, they take the glucose and convert it back to carbon dioxide, so it goes into the atmosphere, and plants use it. We also produce carbon dioxide by burning fossil fuels. Wood is part of the short-term cycle. Fossil fuels are part of a long-term cycle we'll get into later. And again, we talked about this in Chapter 8, Cellular Energy. The carbon dioxide from burning, though, can be taken up by those same producers, converted to glucose, used by producers, consumers, and higher-level consumers to make ATP, and in the process, you make more carbon dioxide. Now, in the process of photosynthesis, you also give off oxygen, and that oxygen goes to the producers who are making ATP with it, or the consumers that are making ATP with it. And those organisms use the oxygen, make water again, which we just saw in the last cycle, and it's actually water that is providing the oxygen. So this really maps out the carbon dioxide, but at the same time we have to overlap that with oxygen coming in. So water comes in through photosynthesis. The water is converted to hydrogen ions that are used to make ATP, and oxygen. The oxygen is used by consumers and producers to burn the glucose, and when you burn the glucose, water is regenerated and carbon dioxide is regenerated. So we can cycle carbon and oxygen through the atmosphere. Another important atom that we cycle through the atmosphere, through the geology as well, is nitrogen. We learned about nitrogen in Chapter 6, the chemistry of biology. It's one of the 4 building blocks of life. It shows up, nitrogen shows up in proteins and nucleic acids. In fact, had we continued to move through the chapters, we would have seen that nitrogen is a major component of the genetic instructions, DNA. We did talk about that in some of our reproduction stuff, and so we just didn't get all the way to Chapter 12, but Chapter 10 for sure. The nitrogen cycle. Nitrogen makes up most of the atmosphere. About 80% of the atmosphere is nitrogen gas. That has to be fixed. That nitrogen gas has to be made into a biologically available form. That usually involves converting it to something like ammonium. And again, there are producers and decomposers that help cycle ammonium nitrogen through the different parts of the cycle. An important kind of plant that does that are called legumes. Legumes are able to take nitrogen from the air, or at least bacteria in them, and take nitrogen from the air and convert it to a biologically available nitrogen. Plants can then use the nitrogen. Plants use nitrogen as they grow. We can also get nitrogen fixed through lightning striking. Just the energy in lightning takes some of nitrogen out of the air and helps to form it into a biologically available nitrogen. And if you ever heard of snow being the poor man's fertilizer, that's because snowflakes pick up some nitrogen from the atmosphere, and when they fall, so they put nitrogen in soil. That helps grass grow in the spring. And nitrogen is an important part of fertilizers. So we have a nitrogen cycle as well. So we have cycled water, carbon dioxide and oxygen, and nitrogen. And there are other cycles, including phosphorus, that may become important the more you get into biology. But they all move from the abiotic parts of an ecosystem to the biotic parts of an ecosystem and back through the use of producers, consumers, and decomposers. Decomposers are very important for getting these individual atoms back into the cycle that they belong. So here we are going to touch on the phosphorus cycle. Phosphorus we saw in chapter 6. It was important as a building block of life. It's also important for cellular structure and function. Phosphorus is an important part of ATP. And in chapter 8, we studied ATP. And organisms use phosphorus as an energy molecule. It is the third phosphorus on ATP. Goes through organisms, consumers, producers, and decomposers, just like we have been talking about. Phosphorus can also be found in the atmosphere. A lot of it is in rocks, however. Weathering naturally puts that phosphorus available into rivers that make their way to organisms. And we also can mine for phosphorus. Phosphorus is an important ingredient in fertilizers. It used to be a lot of phosphorus in detergents, but we try to cut down on that because of some of the problems with phosphorus poisoning. Phosphorus can get in once it gets into the soils, picked up by plants. Consumers get their phosphorus by eating plants. Decomposers return it to the soil. So again, we have a nice cycle for phosphorus. So we have cycled water, carbon and oxygen, nitrogen, and phosphorus. So biogeochemical cycles include the exchange of important elements between the abiotic and biotic parts of an ecosystem. Carbon and oxygen cycles are closely intertwined, and we have spent a lot of time looking at carbon-oxygen cycles, even though we haven't called it the carbon-oxygen cycle. It's really the photosynthesis-respiration relationship. The stuff that comes out of photosynthesis goes into respiration. The stuff that comes out of respiration goes into photosynthesis. And the major components of those are oxygen, carbon dioxide, and even water. Nitrogen gas, although it's very abundant in our atmosphere, is limited in its ability to get into the biotic portion of the ecosystem, the environment. It's difficult to get that nitrogen, which does not react very well with other things, into living organisms. It would be a rate-limiting nutrient in many cases. But there are ways to get nitrogen into the biotic part. We have legumes on plants. Those are bacteria that can take nitrogen and convert it to a usable form. We have lightning. We have snow. There are a number of ways to do it. And phosphorus and carbon both have short-term and long-term cycles. So I said the carbon we've been talking about, the carbon in the photosynthesis respiration relationship, is a short-term cycle. The fossil fuels that we burn are releasing carbon that was captured by plants millions of years ago. So that becomes a long-term cycle. And that's part of the reason that we have kind of upset the balance of carbon in the atmosphere. Though we've released more from the long-term cycle than we are able to deal with, perhaps, in the short-term cycles that are available, and that's why carbon dioxide levels have risen. Phosphorus also has short-term and long-term cycles. Some of it moves quickly, some of it is stored in rocks, and generally that's what long-term cycles are. They're stored in or in rocks or within the parts of the crust of the earth. All right, so that'll give you some slides to go over. Tomorrow I will put up a chalk talk and put up the individual assignments for section 3 of chapter 2. And then towards the end of the week, we'll put up a not a summative, but a more all-inclusive chance for you to see how you do in chapter 2. All right. Thanks again. Stay safe. We are winding down. I guess we got about 3 or 4 more weeks of doing this, and hopefully it'll be a good summer, and we'll be back to it as more normal in the fall.